When you stand beneath the night sky, staring up at the glittering spread of stars, it's impossible not to wonder, are we alone? It's one of the oldest questions in human history. Ancient philosophers debated it, storytellers imagined it, and scientists have long searched for evidence. Across cultures and centuries, this question has echoed, unanswered. But today, for the first time, we have the tools to begin answering it. At the cutting edge of this search stands the James Webb Space Telescope, JWST, humanity's most advanced window into the cosmos. Unlike any telescope before it, Webb was built not just to see farther, but to see differently. Using infrared vision, it can pierce through cosmic dust, study the earliest galaxies, and analyze the atmospheres of distant planets. In a way, it's like a time machine, capturing light that left its source hundreds or even thousands of years ago, carrying the story of alien worlds across the abyss of space. One of the worlds Webb has turned its eye toward is K2-12B, an exoplanet orbiting a cool red dwarf star about 120 light-years away in the constellation Leo. From Earth, it's invisible to the naked eye, just one faint star among billions. But hidden in its orbit is a planet that may reshape our understanding of life in the universe. K2-12B is unusual. It doesn't fit into the familiar categories of our solar system. It's larger than Earth but smaller than Neptune, placing it in a mysterious class scientists call sub-Neptunes. We don't have a single example of such a planet nearby, which makes it difficult to compare. Sub-Neptunes seem to occupy a middle ground between small rocky worlds and gas giants, often wrapped in thick atmospheres and filled with possibilities we are only beginning to explore. What makes K2-12B even more fascinating is its location. It lies in the habitable zone of its star, that delicate orbital band where temperatures can, under the right conditions, allow liquid water to exist. The star it orbits, a red dwarf, is smaller and cooler than our Sun. That means K2-12B orbits much closer to it than Earth does to the Sun, yet remains in a temperature range where life might be possible. When JWST studied the planet's atmosphere, the results were astonishing. Its instruments detected water vapor, a key ingredient for life as we know it. Alongside this, Webb's spectroscopic analysis revealed methane and carbon dioxide, gases that help paint a picture of the planet's chemistry. But the most exciting, and most controversial, finding was the tentative detection of dimethyl sulfide, DMS. On Earth, DMS has a unique origin. It is produced only by living organisms, primarily microscopic life in the oceans. If this molecule truly exists in K2-12B's atmosphere, it would be one of the strongest potential biosignatures ever found beyond Earth. Though scientists urge caution, the signal is faint and needs further confirmation. Even the possibility is enough to ignite imaginations worldwide. But what kind of world is K2-12B, really? Some researchers believe it may belong to a new class of planets called Hycean worlds, a term that blends hydrogen and ocean. First proposed in 2021, these planets are thought to be water-rich bodies cloaked in thick, hydrogen-heavy atmospheres. They may be up to 10 times Earth's mass, with vast oceans stretching beneath dense skies. Unlike Earth-like planets, which need very specific conditions to sustain liquid water, Hycean worlds could remain habitable over a much wider range of environments, even at temperatures far hotter than Earth's. Imagine it. A planet where sunlight filters through a hazy, hydrogen-rich sky, warming an endless global ocean beneath. In those deep, dark waters, life could exist in forms unfamiliar to us, perhaps resembling Earth's extremophiles, hardy organisms that thrive in volcanic vents, under crushing pressure, or in toxic chemical lakes. One of the reasons Hycean worlds are so important in the search for life is that they are detectable. Their larger size makes them easier targets for telescopes, and their atmospheric signals are stronger. This means they give us a realistic chance of studying worlds outside the narrow Earth-like template. In other words, life beyond Earth might not look like life on Earth at all, and Hycean planets open our imagination to those possibilities. To unlock the secrets of K2-18b, the James Webb Space Telescope used a technique called transit spectroscopy, one of the most powerful tools we have to study distant worlds. Here's how it works. When the planet crosses in front of its star, a tiny fraction of the starlight filters through its atmosphere before reaching us. To the human eye, this light looks unchanged. But when Webb's instruments split it into its component wavelengths, something remarkable happens. Hidden within that starlight are subtle signatures, fingerprints of the gases surrounding the planet. In those faint signals, Webb detected the presence of water vapor, along with methane and carbon dioxide. Each one of these molecules tells part of a story, about chemistry, about conditions, about the possibilities for habitability. And in that same spectrum, there may even be a whisper of something more: dimethyl sulfide. On Earth, this molecule comes only from living organisms, especially tiny marine microbes that drift through our oceans. If that detection is confirmed, it would be nothing less than extraordinary, the first strong biosignature ever seen outside our solar system. But here's the truth: science is cautious. One detection is not enough. Future observations will need to confirm it, rule out errors, and explore the deeper layers of K2-18b's complex atmosphere. We also need to understand how its climate works, how heat is distributed across the planet, and whether those potential oceans beneath its hydrogen-rich skies could truly sustain life. Yet even with these uncertainties, the implications are staggering. Imagine this. If just one Hycean planet like K2-18b can host life, and if these worlds are common, as early surveys suggest, then the probability of life elsewhere in the galaxy increases dramatically. Suddenly, the universe doesn't look empty. It looks alive with possibilities. K2-18b reminds us of something profound. The cosmos is not only vast, it is full of surprises. For centuries, humanity assumed Earth was the template for habitability. But this distant planet tells us that life might thrive in places very different from our world. Under thick hydrogen skies, in oceans deeper than any on Earth, orbiting stars far smaller and dimmer than our Sun. We are entering a new era of exploration. Telescopes like Webb are only the beginning. In the decades ahead, future missions may directly image exoplanets, analyze their surfaces, and even search for the faint glow of alien cities or the chemical trails of technology. Each step brings us closer to answering the oldest question: are we alone? The story of K2-18b is still unfolding. With every new observation, we peel back another layer of mystery. Somewhere beneath those skies, in the endless dark of its oceans, life may be stirring, unseen, unfamiliar, but real. As we look outward, we are also reminded of our place within this grand tapestry. The search for life on distant worlds is, at its heart, a search for ourselves, for connection, for perspective, for the realization that we may be part of something far greater than we ever imagined. K2-18b is not just a planet. It is a message from the universe. That discovery awaits those willing to look, that life may not be rare, and that the cosmos is filled with stories waiting to be told. The universe is vast. The questions are ancient. And with every step forward, we are closer to the answer. Somewhere, 120 light-years away, in the shadow of a red dwarf sun, there may be life waiting to be found.